Testing 1, 2, 3. So this is called vectors in space, and basically we are taking what we learned about vectors in chapter whatever it was, 7 or 8 or somewhere around there, and just putting into 3 dimensions. So most of the same things apply. Okay, and so with we did the dot product, right? We did dot product. We did adding, subtracting vectors, finding the magnitude of vectors, multiplying vector by constant, finding the unit vector, finding the angle between 2 vectors, and so we pretty much did everything in 2 dimensions that you're going to do today in 3 dimensions. So it's basically the same stuff, so it should be real straightforward. The reason that we talk about vectors in 3 dimensions so that we could talk about the cross product, because the cross product is kind of what you get when you multiply 2 vectors in a certain way. You get the vector that's perpendicular to both of those. So you kind of have to talk about the kind of less interesting properties about vectors to talk about the cross product. So in any case, a vector in space is an ordered triple, which means you can call a some vector v, and they use like a dark or a bold small v, is equal to v1 comma v2 v3, so you could break a vector into an x, a y, and a z component is basically what it means. So instead of having x and y, we have an x, y, and z. Okay? You can write a vector in IJK form. They call it unit vector form, I think, in the book. But you can write it like this: v equals v1 times in the I direction, which is basically the x direction, plus v2 in the j direction, plus v3 in the k direction. Okay, so I, j, and k correspond to the x, y, and z directions, where I is equal to the unit vector 1, 0, 0, and j is equal to the unit vector 0, 1, 0, and k is equal to the unit vector 0, 0, k. That's 0, 0, 1. I wrote 1, and I said k. So in other words, if I have some vector, right, and here's, so some vector, let's make it a different color, and let's make some vector going out this way in space, okay? And I could break that into one vector going either positive or negative this way, one vector going either negative or positive this way, and another vector going negative or positive this way, and multiplying each one of those components of this vector by some magnitude, and I would get this vector right here. That's kind of what that is. That's kind of what this is saying. So I, j, and k are unit vectors, meaning they're 1 unit long in the I direction, 1 unit long in the j direction, and 1 unit long in the k direction. Okay. The zero vector, which they indicate with a bold 0, so they make it dark. It's kind of bad. Is just equal to 0, 0, 0. That means you go over 0, up 0, over 0, over this way 0, and up 0. Okay? So that's the zero vector. Component form of a vector, components. So this is called unit vector form. Unit vector form, and this is called component vector form. If you have a point for a vector from P to Q. Okay, so remember that a vector not only has a magnitude but it also has a direction. Okay, is given by it's given by if we're where point P has the coordinates P1, P2, P3 for the X, Y, and Z points, and Q has the points Q1, Q2, and Q3. That's with a comma, because you're not at a, this is just indicating a point. The way you get the component form of the vector v, okay, is equal to its parts, which are like just up here, v1, v2, and v3. But to write it, if you go from point P1 to Q1, the way you get that vector is by subtracting. So we get point Q1 minus point P1, comma, point Q2 minus point P2, comma, point Q3 minus point P3. Okay, so that's called the component form of a vector. Okay. The magnitude of a vector. Does anyone remember how we find the magnitude of a vector? Magnitude of v, okay, which is given by this symbol with two bars on the edges. Okay, it's just the Pythagorean theorem, the square root of its component squared. So it's v1 squared plus v2, the square root of v1 squared plus v2 squared plus v3 squared. Questions on that? We'll do a bunch of examples, but I'm just kind of trying to give you all the stuff you need. Okay. Then we have the unit vector. Unit vector. Anyone remember what a unit vector is? Very nice, Ashley. It has a magnitude of 1, okay, of 1 is given by this small u, small dark u, equals 1 over the magnitude of v, or 1 over the magnitude of v, that's sloppy, 1 over the magnitude of v times the vector itself. Okay? So in other words, if you have some component form of a vector, like 3i plus 2j plus 4k, or in the other form where you just are listing v1, comma, v2, v, comma, 3. What you do is you just divide by the magnitude. We'll do some examples right in a second. I'll show you in a minute. uv let u equals, I think you know how to add vectors. I'm not even, to add a vector you just add their components. I think you can figure that out. To multiply a vector by a constant, so if you, or a scalar, so k u, so this means some, yeah, we already did this with 2 dimensions, okay? So ku is equal to, if u is some vector, is equal to k times u1 plus k times u2 plus k times u3. That's if u is equal to the vector u1, comma, u2, comma, hey, u2, u3. All right. Okay. So So all that's saying is you can multiply a vector through by a scalar quantity and get a longer vector. Okay? So let's just do a couple examples. You want to write that down, or we're done? Can I move on?
No, we can.
Right, next page. I always get confused between component form and standard form. Component form. We'll just do an example. Okay, so it's new page. Where's my new page? New page. And then we'll do a dot product. So find.
Mr. Leader, I think what you said was unit vector form is
So to clarify, the unit vector form is when you have the ijk's, and the component form is just when you have component like v1, v2, v3. Okay? So find the component form of the vector. Components. So this is without the ijk's. Component form of a vector from the points, and notice these are curvy things because these indicate points. 2, -4, 1, 2, -4, 1, 2, -4, 1, 2, 5, 7, 0, 5, 7, 0, and then find the magnitude and unit vector. So all you'd have to do is write that V is equal to, you just subtract this minus this. So it's just going to be 3, what? 11 and -1. That's all there is to it. So that's the component form of the vector. Okay. The magnitude is just the square root of 9 plus 121 plus 1, which is square root of 130, right?
131.
I knew that. Mrs. Voss distracted me.
I did. I
131.
apologize. I didn't know if you needed the assignment that I gave today or
Oh.
not.
Okay, I made my. It's pretty simple, almost
Yeah,
the same.
yeah.
Okay.
I didn't do any of the rationalizing or any of the
Wait,
branching
we're
and
being
stuff.
recorded.
Sorry.
So, moving on, find the magnitude in the unit vector. And then, so the unit vector would be 3 divided by the magnitude, which is square root of 131, comma 11 divided by the magnitude, which is square root of 131, comma 1, -1 divided by the square root of 131. Do you guys understand that? What that means? Okay. So, in other words, if I were going to draw a picture of this, not very good picture, but in 3 dimensions, okay? And let's do it this way. And if I have some vector that is going out this way 3, over this way 11, and down 1. So it might look like, let's put an arrow on the end, okay? So it might look like, let's make it solid. Let's make it pink. So it might look like a vector that's going down like this or something, right? The unit vector is, so the magnitude of this, in other words, if I were to measure it or using it as a force or something, it'd be the square root of 131, right? Which, whatever that is. Well,
How long it is?
yeah, it's, well, how long it is, but vectors usually represent a speed. You know, yeah, if you're graphing it, it's how long it is, but it usually represents a speed or a force being pulled on something. You know, but so the unit vector is just a vector in exactly the same direction, but its length would only be 1, right? Because you're dividing by 131. So they, that would be the unit vector, u. Right there would be that. Whereas the vector itself would be this long thing. Okay? You understand that? Okay? Then we have the dot product. Okay? So the dot product, which we've already done, u dot v in 3 dimensions, is just u1 times, this is a time sign, u1 times v1 plus u2 times v2 plus u3 times v3. So find the dot product for u equals 262, 262, and b equals -150. -150. So the dot product, again, is one form of multiplying vectors together, and the dot product gives you a scalar, meaning it gives a number, whereas the cross product, which we'll learn about tomorrow, that gives you an actual number, actual vector. Okay. So u dot v in this case is just going to be 2 times 1, right? 2 times -1. Moby's kind of getting tired here. Plus 6 times 5 plus 2 times 0, which is equal to whatever that's equal to, -2 plus 30, 28, right? And what does that tell you? It tells you what you get if you multiply those 2 vectors together. But it's useful if you're trying to find the angle between 2 vectors. Okay? Which I'm going to talk about now.
28 is the dot.
28 would be the dot product.
Okay.
Yeah. Okay? So the angle between 2 vectors, which we learned in the last chapter, or last time we talked about vectors in 2 dimensions, angle between 2 vectors. Anyone remember what that formula is? Cosine, it's cosine theta is equal to u dot v, which is the dot product, u dot v, not over the magnitude of u times the magnitude of v. Does this look familiar from last when we did this chapter on vectors? Okay. So let's find the angle between these 2 vectors. So find, and that angle theta has to be between 180, less than or equal to 180, and greater than or equal to 0. Okay. And so if this thing is equal to 0, what would have to? Well, that's not necessarily true. Never mind. So find the angle. That says angle. Angle between u and v up here. Okay? So all we're going to do, we already got the dot product. So cosine theta is equal to 28 divided by the magnitude of u. What's the magnitude of u? Can you guys do that in your head? 4 plus 4 plus 36. 44. Thanks. All right? Yeah, that's right with us here. Okay. And over here we got 1 plus 20 squared at 26. And so what I need to do is take the inverse cosine of that quantity. And so I didn't do this problem beforehand. So I'm going to do it right now. So Let's get my handy dandy graphing calculator out here, and make sure that I'm in.
It's 34.12.
Oh, you did it for me, Marion. Okay. Yeah, this takes too long. So I believe Marion.
Thank you.
Okay, so I'll just believe you, Marion. So Marion says that this comes out to be what?
34.12.
34.12 degrees. Okay, so that's how you find the angle between two vectors. And then and two more things. Two more things. And then we'll be done. Go back. You want to write that down? Shoot. Oh, well. Okay. I didn't know in college my friends really encouraged me. They said, "Oh, you're so funny. You should come and do stand up." And it was right down here. I went to see you in the restaurant is still there on Arapahoe, and I went there and they had like open mic night, and I tried to tell jokes and I just froze and I couldn't do it. So when I feel comfortable, I could be okay. Okay, so two vectors are parallel. Okay, if u is equal to they say CV, where C is a constant. Okay, so I think it's kind of harder to tell in 3 dimensions. So like you don't really know if they're parallel in space like you do. Like I don't think you could use the formula that cosine of theta equals 0. Okay, but what you can use is if you multiply one vector by a constant and you get the other vector, that's how you could tell if they're parallel. So what they say is like, is u, which is equal to 2, 6, 1, parallel, that means parallel, to v, which is equal to 1035. 1030, 5. I got kind of squished. 1030, 1035. The answer is yes. Why?
Because the constant
Well,
is 5.
right, because if I take u and I multiply it times 5, right, I get this vector over here, right? So 5 times that gives you 10, 5 times that. So in other words, they're both going the same direction, and one is just 5 times as long as the other. Yeah? Okay, so that's that. And then the last thing, I think the last thing is too easy, but we'll do it anyway. Okay, they do have one on the static equilibrium. Do you guys remember doing that last semester where you had was it last semester or was it this semester, where you have a weight hanging down and then you have a weight going straight down this way, and then you have to balance those forces. But in this case, you have 3 things hanging down, and you have a weight pulling down this way. Well, I spent time preparing that problem, but Mr. Beamer said he's going to skip it, so I said I'd skip it too. Okay, so you'll be happy about that. But, so you would balance the x, y, and z components and all that kind of stuff. But anyway, last thing, this is just an example type of problem that you'll see. The terminal point of a vector Wow, I wasted a lot of time. Vector is 1, 1, 3, 5. Oh, sorry. I messed up. Of a vector v equals 1, 3, 5 is q 2, 5, 8. Okay. What is the initial? What is the initial point. Would you be able to tell me how to do that? And we'll call the initial point P. What's the initial point P? How do I find a vector if I know the terminal point and the initial point? Yes, Sam?
You know, the component form is the terminal minus the initial.
Right,
And all these directions.
right.
So you can plug in a terminal point into that equation and set it equal to the component form.
Right.
of the vector.
Yeah, so you just do like this. You go, you would say, so if P has if P is the vector P1, comma P2, comma P3, right? Or if P has those coordinates like that, you know that 1 is equal to, since this is the endpoint, 2 minus P1, right? And you know that 5 is equal to what minus what? Sorry, that's wrong. 3 is equal to 5 minus P2, right? And you know that 5 is equal to 8 minus P3. And then you just solve for that, so you get, here you get P1 equals 1, right? Is that right?
Yep.
Yeah. P2 equals 2,
Yep.
I think. And P3 equals 3. Alright, so you get that P is, so point P is 0.1, comma 2, comma 3. So you can have to do some thinking in reverse. Yeah? Got that? Easy? Alright, so that's about it. Your homework is, where's your homework? On my website.
Maybe you don't just use brackets or parentheses when you write the vector.
You don't have to use graph paper. Pre-calc advanced assignments, if you want to.
Was that a good question?
Was that your question?
Brackets. No, I said when we write the vectors, do you want parentheses or brackets?
Brackets. If it's a vector, brackets. A point, you use parentheses.
Wait.
For a vector, you use the, right? A point is you use parentheses, but for a vector, you use the.
No brackets.
Okay?
Sure.
Yes.
I need help on my math section. I come in on Thursday. Wow.
That's Joe.
Who's this? Wait, Kennedy.
Yeah.
Thursday during tutor time. Hold on. Let me stop my video.